Lesson 63, we're going to talk about the addition of vectors, and it starts with a word problem. It's not always going to be a word problem. These are just going to look a lot simpler, but it says flying arrow left the village and traveled 20 miles on a heading of 20 degrees. From this point he traveled 40 miles and on a heading of 210 degrees. How far did he end up from the village? So it was like Bear Grylls stuff here. How we solve for these, if you remember polar coordinates, I'm going to go ahead and draw a little graph here just to show you what it would look like, because that's how you solve for these addition of vectors. It says he traveled 20 miles on a heading of 20 degrees. So many of y'all remember kind of what that looks like. 20 miles at 20 degrees. That's our polar coordinate. What we're going to do is imagine putting this on a coordinate grid. Well, remember we started 0 and 360, 90, 180, 270. This one's pretty easy to see because it stays in this first quadrant. Go counterclockwise, 20 degrees, all right, and create our little triangle. So this is a 20-degree angle, and our hypotenuse is 20 degrees. So if we're drawing a triangle, what our triangle looks like is this. So we've got a right triangle. We're going to come back to that in a second. I want to go ahead and graph the other one, the other, distance vector, whatever it is. It says from this point, he traveled 40 miles on a heading of 210 degrees. So then, from this point, that means he added 40 miles of 210 degrees. So if I wrote a problem like this, we would solve this the same as here, but this is what it looks like algebraically. 20 at 20 degrees plus 40 at 210 degrees. And so from here, we find 210 degrees. What is that between? It's between 180 and 270. And so we go all the way from here to roughly right there. Looks good. And this angle total is 210 degrees. However, we want this triangle. We know the hypotenuse is 40. So I'm going to take this triangle, put it over here. What is this angle? I'm calling it theta right now. Well, remember to find theta. What we have to do is subtract our total from the horizontal, or it's the absolute value of the horizontal from your total. So we do 210, our total amount of degrees, minus our horizontal measure here is 180. And absolute value, I'm not going to put those around because we already know it's going to be positive, it's going to be 30. So this angle is 30 degrees. So now we have our triangles, and we're basically going from polar form to rectangular coordinate form in both of these. If you remember rectangular coordinate, we're trying to solve for r and u. We already actually know that this r is negative, excuse me, and this u is negative because it's going left and down. But we solve by using sine, cosine, and tangent. So here, if we're finding r using SOHCAHTOA, we need to use the adjacent for r, and 20 is our hypotenuse, so we're going to use cosine. Cosine of 20 equals adjacent r over hypotenuse 20. Isolate r, so we have 20 cosine 20, and that is 18.79. I'm going to put that all the way over here. 18.79 r. Now we solve for u. So if we're doing u, that's going to be the opposite of 20, and hypotenuse is what we're going to use. So sine 20 equals u over 20, get u by itself. So 20 sine 20, 6.84. So plus 6.84 u. So we've got this triangle taken care of. Now we got to solve for the other one. Now the other one's nice to us. It gives us a 30-degree angle. We already know this is 90, so the other angle is 60. So I'm going to go ahead and use our 30, 60, 90 shortcut that we've discussed recently. And so 30, 60, 90, if you remember, the small leg is half of the hypotenuse. So the leg opposite of 30 degrees is half of our hypotenuse, which is 40. So therefore this is 20. And our long leg is our short leg times radical 3. So that would be short leg 20 times radical 3. And yes, these are negatives. So how we add our vectors together is we simply line them up. I am going to put that in decimal form. I'm going to put that in my calculator. 20 radical 3, 34.64. Put that over here. So negative, what is it, 34.64r minus 20u. And then we're basically solving top and bottom. So over here I'm going to do 18.79 minus 34.64, get negative 15.85 r. I already know this is going to be negative, but 6.8 minus 20, and we get negative 13.2 u. So here is our vectors added together. The book rounded a little bit, but ours is the same thing. That's how you add vectors, though. Let's look at one more example. This one is easier to see. They wanted to make that first one difficult and put it in a word problem form. But the next one says, in example 63.2, it says to add vectors 30, or add 30 at 55 degrees and 10 at 170. 10 at 170. So, I'm going to use the other marker because this one's kind of dying. Create our triangles. 55 is between 0 and 90. So I'm going to shortcut this one since we know it's in the first quadrant and put 30 and 55. Put it on a coordinate grid. That's where it would be. Just so you can see it. And then our other one, let's go ahead and map this one out. 90, 180, 270, 170 is between 90 and 80. So we go about 170, stop, make our triangle. Remember, always connect the triangle to the horizontal. So we have a hypotenuse of 10. Now what is this angle? It is our horizontal, is the absolute value of our horizontal minus our degree. So 180 minus 170 is a measure of 10 degrees. So we have a hypotenuse of 10 and a theta, or degree of 10. Now we solve. We got to find r and u. We know they're both positive here. This one's a negative r since it goes to the left, but it is still a positive u. So let's solve for r using TOA. Which of these three uses adjacent and hypotenuse? Well, that would be cosine. So cosine of 55, our starting point, equals adjacent r over hypotenuse 30. We multiply both sides by 30 to get 30 cosine 55, 17.21. 17.21 R. Then, if you haven't figured it out yet, the U always looks the same as the R. The only difference is its sign. So I'm going to shortcut again there. But it's always the same. Notice it's 30. Cosine and sine are the only things that switch, and then you have 55. So you can shortcut a little bit once you get the hang of it. I'll solve this one like we do traditionally, but shortcut this one and we get 24.57. Now we go to the other triangle. All right, we got to solve for R, so adjacent over hypotenuse would be cosine of 10 equals adjacent R over hypotenuse 10 multiplied by the 10. 10 cosine 10 is 9.85, and it is a negative R, so we turn this into a negative 9.85 R. We already know that's positive U, so go ahead and put a plus sign. Solve for U. In relation to 10 degrees, U is opposite, and 10 is hypotenuse. So we use sine of 10 degrees equals opposite. Our letter here is U over hypotenuse 10. Multiply the 10 to get U by itself. And 10 sine of 10 is 1.74 U. Now plug these in our calculator and add. So we get 17.21 minus 9.85, 7.36 R, plus 24.57 plus 1.74, 26.31 U. There's our answer, and that is how you do addition of vectors. Got to get them in rectangular form and then add them together.